So this is going to be the only section we do in Chapter 10. Normally I do 10.1 and 10.2, but we're going to be skipping 10.2. Also, in terms of the sections, this is like the highest section we get to, because next week we go back and do some stuff in Chapter 8. All right, so we're really done with Chapter 9 and 10 in this week. And we didn't do very much. So section 10.1 looks at what's called solving systems of equations. Bless you. When you're solving a system of equation, the goal is to figure out the answer to the variables, plural. Okay, that's what a system is. It's when you're solving for a minimum of 2 variables. We're going to do some 2-variable problems and some 3-variable. And we also might do one graphically. I know the section says algebraically, but we might do one graphically. So that answers part of my next question. Different ways you can solve systems of equations from Algebra 1 and 2. One way is to graph them and see where they cross. What's another method you can use for solving a system of equations? Yeah? You can use a matrix. That would be in section 10.2, which we're not going to quite get to. I'm going to mention it, but we never learn how to do it. So a matrix is one way. What's another way to solve a system? Anyone remember how to solve a system of equations? Yeah.
Making them full.
Can you summarize that in a single word for me?
Sending to 0.
No time. Yeah.
Substitution.
Substitution. So that's one way to solve a system. And there's one other way besides substitution. Yeah? Elimination. Yeah. And elimination is what using a matrix is based on. Substitution is okay when you have a small number of variables, but if you have a big number of variables, substitution becomes kind of challenging. So we're gonna focus on elimination when we get to a 3-variable problem. All right, so for this first one, I just want to set it up. I don't want to solve it. Solving it's actually going to be example 2. So just set it up. So the problem says to find the length and the width of a rectangle where the perimeter is 100 and the area is 300. Well, the first thing you have to do when you're setting up equations from a word problem is you need to pick letters you're going to use as variables. What letters do you think would be good letters to use in this problem? Yeah?
L and W for length and width.
Yep, L and W for the length and the width. Those are the 2 things we need to find. L and, let's actually put the W with the W. Okay, let's start with the perimeter. Can someone tell me what is the formula for the perimeter of a rectangle? Yep.
2L plus 2W.
2L plus 2W. So 2L plus 2W is the perimeter. And what do we know the perimeter is? Yeah. We know it's 100. Okay, so there's one equation. Now I need to write a second one. If all they told me is the perimeter is 100, I can think of lots of rectangles with a perimeter of 100. I could do 25, 25, 25, 25. That's a rectangle. I could do like something like 5 and 5 and 45 and 45. That's a rectangle with perimeter of 100. There's lots of them. But what's going to narrow this down is the fact that the area also has to be 300. So what's the formula for area of a rectangle? Length times width. And what do we know that our area is equal to? Yeah, 300. So there's the two formulas that they wanted us to set up. Any questions on how we set those up? Okay. So some problems are more appropriate for substitution, some are better for elimination. We're going to focus on both of those methods in this section. So the first one I'm going to talk about is substitution. So we'll go through what substitution is, how you do it, and then we'll try it. Okay, so how do you use substitution? Does anybody remember, like, if you had, let's say something like this, y plus 2 equals, 3x, and 2x plus 4y equals 12. If you wanted to solve that with substitution, what would be the first thing you have to do? Okay?
Would you want to get the 3x on the left?
You have to do some kind of rearranging with a goal in mind. What's the goal you have to do? You could leave the 3x on the right. You could put it on the left. I would probably leave the 3x where it is. You're focusing on the right. You're focusing on the correct equation, though, that you probably want to do something to. Declan?
Try to get one of the variables isolated.
Try to get one of the variables isolated, right? So pick an equation and solve it for a variable. I think the top equation in that problem would be the easiest one to solve for a variable, because one of the variables already has a coefficient of 1, which means you're just going to have to do one step to isolate a variable. Okay, I would just minus 2 on both sides. Now, once you have a variable isolated, like in the top equation, you'd have something like this. I'm not actually going to solve this problem, I'm just using it kind of as we go through. So this one is gone. You don't need it anymore because you rewrote it. What would you do now once you've solved for the y variable? Yep.
Take the equation you didn't do anything with and substitute y for the new equation you just wrote.
And you're going to take what you just got for y there, and you're going to plug it into the other equation. So plug in the result from step 1 into the other equation. Once you do that, you're going to know the answer for one of your variables. Which variable you know, can you just sign back in for me? Which variable you know is going to depend on which one you solved for. It depends on how you did it. Now, what do you do? In this case, you're going to know the x variable. What do you do after you know that one? Yep.
You plug into the original equation.
Yeah, you plug it back into one of the original equations, and then you find the y variable. So in general, take the answer that you got from step 2, plug it back in, and find the other variable. It doesn't matter which equation you plug it back into. Plug it into whichever one you think is easier to work with. So we're going to go back and we're going to do the first example we wrote down, but we're going to do it with substitution. Now, I changed the L's and W's to X's and Y's. It really doesn't have any effect on the problem. So we'll just try it that way. All right, so first thing, we're going to decide which equation we want to try to get a variable by itself in. Do you think it's easier to isolate the X or the Y in the top or the bottom? Declan? I'd say the bottom. You can really do it in one step. Which variable, Declan, you want to get by itself in the bottom?
I'll do X.
X. So if you get the X by itself, what would be in this box?
300 over Y.
Yep. 300 over y. All right, and now, Kelly, what am I going to do with that 300 over y?
You're going to substitute it in the top equation for x.
Yeah, I'm going to substitute that in the top equation for x and see what we get. So 2y plus 2 times 300 divided by y equals 100. So all I did was substitute x 300 over y for x. All right, we can simplify that a little bit. So 2y plus 600 over y equals 100. Now, generally what you want to do at this step is if you have fractions, we want to try to get rid of the fractions. That usually means multiplying everything by something that would cancel out all your denominators. What could we multiply by here that would cancel out my only denominator? Yeah?
Multiply by y.
Yep, I'm going to multiply by y. We have to do that everywhere. And this is purely so we don't have to deal with fractions. So that's going to give me 2y squared. So now you should already have a hint at what kind of problem you're going to be solving. Highest exponent is a 2. It's a quadratic. So 2y squared plus 600 equals 100y. When you're solving a quadratic, what do you generally try to get it equal to? Yep. 0. So we want to put everything on the left side. 2y squared minus 100y plus 600 equals 0. Now, what's one way you can solve a quadratic? Yep.
Factor.
You could try to factor it. I don't think this one is going to factor nicely. So what's another method we could use when factoring does not work? Yep. Yep. We're going to use quadratic formula. Now, you could jump right in and do quadratic formula, but there's something I would do first just to make things a little bit smaller. Yep. You can divide everything by 2. It's not necessary. Doesn't have any effect on the final answer, but at least it gives me some smaller numbers. Okay, so let's identify A, B, and C, and then we'll use quadratic formula. Quinn, what's A?
Y squared.
It has to be a number.
Oh, 1.
1. Yep. The number in front of the y squared. A, what's B?
Negative
50. And Brighton, what about C?
300.
300. Okay, so let's put all that in the quadratic formula and see what we get. So negative b plus or minus the square root of b squared minus 4 times a times c. That's 4 times a times c all over 2a. Now, right away, just by writing this down, plus or minus means how many answers does this problem have? 2. It means it has 2. So there are 2 rectangles that are going to satisfy the answer to this problem. So we've got 50 plus or minus. What's 4 times 1 times 300? And what's 2,500 minus 1,200? 1,300. So there are your 2 answers for y. Let's round them off. That's the exact answer. But the approximate answer is 50 plus the square root of 1,300 divided by 2. So it's about 46.023. No, 43.023. Sorry. And let's call that y1, because that's our first answer for y. And let's do y2. 50 minus the square root of 1300. And then divide that by 2. 6.972. Okay, so we've got a y1 and a y2, but this is a system. So what else do we need to find? Yep. X. Which x? Both of them, x1 and x2. So we still have to find both x's. Well, once you know the y's, the x's are easy, because you have a formula right here that tells you how to get x. Take 300, divide by y, and that'll give you x. So 300 divided by y. Let's do it. 300 divided by mess that up. 300 divided by 43.023. I got 6.973. And now we have to find x2. So 300 divided by y gives you x. 300 divided by 6.972. 43. Well, if we round it, it's like 43.03. It rounds up. 43.03. What do you notice about these two answers? Yeah.
Y1 is similar to x2 and x1 is similar to y2.
Yeah, they're basically the same answers. The only reason they're not exactly the same is because I rounded. But I mean, it's pretty close. 0.02, 0.03, 0.973, 972. They're the same thing. So what that really means is the two answers to this problem. Well, one is a rectangle that looks like this. And the other answer is really just thinking of that same rectangle like that. Those are the two answers. So the only difference is it's rotated a different way. But they are the same, basically the same rectangle. Any questions on that one? That's also the only quadratic system that we're going to solve. Most of the systems we're going to do are linear. I mean, one answer for x, one answer for y, and you're done. Okay, so questions on yeah.
How did you get 6.972 for y2?
Y2, 50 minus the square root of 1300 divided by 2.
Well, how did you get the first one?
The first one, 50 plus the square root of 1300 divided by 2. Yep. All right, let's try this one. So another substitution, but this time just a linear system, no quadratic. Okay. Jazaro, which equation here do you think would be easier to isolate a variable? First one? And what letter would be the easiest to get by itself? Okay, let's do it. If you get y by itself in the top equation, can you tell me what you get? Yep, so you get negative 2x plus 5. All right. Eli, what am I going to do with that negative 2x plus 5?
Plug it into the other equation.
Yep. Plug it in for which letter? Yep. plug it in for the y, and then write out what you get. So 3x. Remember, anytime you substitute, make sure you keep it in parentheses because a lot of times distributive property is going to be involved. So
Stop it.
3x plus 2, and then I substituted for y, equals 2. Wyatt, what's the first thing I'm going to have to do there? Okay, can you tell me what you get when you distribute that out?
Negative 4x.
It's 10. Okay, Matt, my next step.
Move the 2 to the side.
Well, the goal now is to get the letter by itself. So we don't want to put more stuff with the letter. We want to start to combine things and then move them away from the letter. No, Maddie, can you tell me what you do
Combine
next?
like
Combine like terms. And what are your like terms?
the 3x and
What's 3x minus 4x?
4, negative.
Negative x. All right. Sam, what would you do next there?
Would you first divide everything by -1 to make sure the x is positive?
You can do that now, or you can do it later. Either way, let's do that after the step I'm thinking of.
You could just minus 10 on both sides.
Yeah, let's minus the 10 first. So that gives you negative x equals negative 8. And now let's do what Sam said. Divide everything by -1. So x equals 8. Okay. So we got x equals 8. Manny, what do I have to do with that now?
You're gonna plug the 8 into 4x in either of the two equations.
Yeah, you could plug it into either one of them. I would plug it into the one where y is by itself because that'll be the fastest way to get y. So now we're going to get y equals -2 times 8 plus 5. So what's y? Yeah. Good. -11. So that's more typical of the kind of systems that we're going to be solving, where you get one answer for x, one answer for y, and you're done. Right, that's also the last one I think I'm really going to do with substitution. Is there any question on substitution? All right, so elimination. The basic goal with elimination is to get something that would look like this. The goal is to make it so that when you look at one of your columns, one of them has a number, and the other column, the one below it, has the opposite of that number. So when you add these columns up, the x's cancel out, or the y's cancel out. But you need a column to cancel out. That's how you do elimination. So you're going to add one equation to another. And I put the word linear combination there because sometimes the variables don't cancel right away, and you need to multiply by something first. That's called a linear combination. So our goal is to get the coefficients of one of the variables to be opposites. And I would say most of the time you're going to have to multiply through by a number in the entire equation to make that happen. Sometimes just one. Sometimes you have to multiply both. We generally want to avoid multiplying by a fraction. We don't want to get into fractions because then it's going to start to get kind of messy. So we're going to stick with multiplying through by an integer. 5, -2. You cannot multiply through by 0. Multiply by 0, then you just wiped out your whole problem. So we'll start off with a system of 2 equations with 2 variables, but eventually what we're going to be getting to is 3 equations and 3 variables. That's kind of the big thing for today. 3 equations and 3 variables. But if you can do 2 and 2, 2 equations, 2 variables, 3 and 3 is longer, but it's based on the same idea. So any question on the goal? What I mean by making one column have opposite numbers in it? Let's take a look. So first thing I do is I look at it right away and say, well, it's not really set up for substitution because I don't have a variable by itself. But do I have a column there that I can add right away and things would cancel out? Okay?
No.
No. Then I'm going to have to multiply this entire equation by a number. Maybe the top or the bottom. Maybe both. So let's pick a variable that we want to make cancel out first. Either x or y. Start. Yeah.
I'll do x.
Okay, so we're going to make x's cancel out. That means we need to have a number in the top and the opposite of that number in the bottom. Can we multiply 2 by something to get 3? Because if we could get 3 here, 3 and negative 3 cancel. But can we multiply 2 by something to get 3? I don't want to use fractions. Yeah?
No.
No. So then what that means is we are going to have to multiply both equations by a number. And what number could be our goal here? We want one of them to be a positive of this number and the other one to be a negative of this number. Yep?
6 and negative 6.
Yeah, we want to try to get a 6 and a negative 6. What could you multiply the top equation by to make this a 6? Yep.
That's right.
3. And what could we multiply the bottom equation by to make this a negative 6? Yeah. 2. Let's do that and rewrite our equations. Chris, if I do that in the top, what will I get?
You get 6x plus 9y equals 2.
Okay. And Ashley, if I do that in the bottom equation, what will I get?
Negative 6x plus 10y plus 42. Or equal to 42.
Now, add them up. X column eliminated. That's why this is called elimination. So X's are gone. And we get 19y equals 57. And you will get a nice answer for that. What 19 times what is 57? Yep. 3. Perfect. Okay, so y is 3. Now, just like with substitution, this part's the same. Take the number and plug it back in and solve for x. Which equation do you think would be easier to use? Either one will work. But I would have a preference over which one. Yep. Yeah, I think the top numbers are smaller and there's no negatives. So let's plug 3 back in right there. So we get 2x plus 3 times 3 equals 5. Notice I'm not using the one that I made bigger, multiplying by 3. I don't have to use that one. I can go back to the original one. Why not? So 2x plus 9 equals 5. And when you solve it, you'll get x equals 2. Negative 2. Yes, thank you. 2 times negative 2 is negative 4. Negative 4 plus 9 does give you 5. When you write your final answer on Elastic, you might set it up so there's like a box like this. You just put your X answer in that box and your Y answer in the one below it. Or I might set it up so you write your answer as a coordinate. Either way. Any questions on that? So now think about these as pictures. If you drew this one on the calculator and you drew this one on the calculator, what would be happening at the point negative 2, 3? If you drew those two lines, yeah?
They'd be crossing.
They'd be crossing. Yep. So there's 3 different things that can happen if you draw 2 lines. In the last problem, they would do something like that. They would cross in one spot. What else can happen if you draw 2 lines? Yeah? They could be parallel. And what do you think the solution would be to a system where the lines are parallel?
No solution.
No solution. And there's one other thing that can happen. It can be parallel, they can cross in one spot, or, yeah? And what would that mean if they cross in multiple spots? How would that look?
It would be curved line.
Lines can't curve. So they have to be straight. So we're talking specifically about just lines. But if it curved, yeah, like a parabola and a line could cross twice, definitely. Yeah? They could be overlapping. They could be the exact same line. So those are the 3 things that can happen. One solution, the lines cross in like an X shape. No solution would mean if you tried to draw it out, you'd get parallel lines. And infinite solution means you have 2 lines that are right on top of each other. We're not going to really focus on the graphing to figure this out. We're going to focus more on the algebra to figure it out. Right, so we'll try a couple of these special cases, and then we're going to finish up with a 3 variable problem. All right, let's try this one. Let's say we want to eliminate the x's. If I want to eliminate the x's, look at the smaller number and see if I can multiply it by something to make it the opposite of the bigger number. Is there something I can multiply the top equation by to make it the opposite of what's in the bottom? 3. So when you multiply the top by 3, you get 6x minus 9y equals 15. And we didn't do anything to the bottom. Let's
The bottom's equal to
10. Yeah, I don't know why I wrote that. I don't know why I wrote that either. Having a tough time. Alright, equals 10. Alright, let's add the first column. What happens there? Cancel. Second column. Yeah?
same thing.
Cancel. So what? We got to put something on this side. 0. And what goes on the right? 25. Okay, we're done. So 0 equals 25. When all your letters cancel out, it means it's one of these 2 special cases. Well, which one is it? 0 equals 25. Yeah?
No solution.
That's no solution. If you end up with a statement that's not true, that means it's unsolvable. Okay, so that's a no solution. Let's try this one. Yeah.
We always figure out in that step if it's no solution or not, or is there some instances where you have to get farther into the problem to figure that out?
No, once all the letters are gone, you're done. There's nothing else you can do. So if all the letters are gone at that point, now you know, okay, it's a special case. Yep. All right, let's try this one. If I want to eliminate the x's, I don't think you're going to have to multiply them both, just one. What could you multiply by? Yeah?
The top one by 2.
Multiply the top one by 2. It's going to give you 2x minus 6y equals negative 4. The bottom one we keep the same. Okay. What's 2x minus 2x?
0.
What's negative 6y plus 6y?
0.
So we'll get 0. What's negative 4 plus 4?
0.
0. So this is another special case because all the letters are gone. So now it's one of these two. It's either no solution or infinite solutions. Which one? Infinite solutions. We could also say like all real numbers. Every single number is a solution to that problem, no matter what you plug in. Okay, so we've really covered everything that can happen with two variables. We looked at a regular case, a no solution case, an infinite solution case, and we did substitution and elimination. Any question before we look at a three variable problem? So, the thing that happens with a three variable problem is, now if you think of like, here's your two variable problem. Well, to get to a three variable problem, the time starts going up, right? And then if you go to like a four variable problem, it gets even longer. So the way we're learning for like four variable problem, we would want to go to a matrix because that's going to make it faster. But a matrix, that's a whole nother lesson to learn about. So we're going to go to three variable. It's not awful. It's starting to take more time. But we're going to learn the same method we've been using, elimination, on a three variable. So it's more confusing to explain it than to just really do it. But I'll try to explain it, and then we'll go from there. So you're going to have three equations. You're going to have three variables. Here's an example. Something like that. The first thing you're going to do is you're going to focus on one variable to eliminate in two of the equations. One of the equations you're going to forget about for now. So we're going to focus on two of the equations, and we're going to eliminate a variable. Let's see if I can word that any clearer. So, I don't know if I can. Pick one variable to be eliminated in two of the equations. Let me add something to it. Then, eliminate that variable again. But you have to use two different equations. So then eliminate that variable again in two different equations. So you're going to pick a variable to eliminate in two equations, and then you're going to eliminate that same variable again in two different equations. It's probably going to be clearer when I just do an example. So let's just go through it. So to do step one, the best case scenario is you have an equation that has a variable with a 1 in front of it. That's going to make it the easiest to do. Do we have an equation here that has a 1 in front of one of the variables? Yeah?
Yes, the third one.
Okay, so I'm going to use the third one. Let's call this 3. Any number that I write down circled is going to represent an equation. Okay? Equation 1, equation 2, equation 3. So let's take equations 1 and 3. And my goal, okay, I'm going to kind of lead you through it a little bit. I want to try to eliminate x in equations 1 and 3. Why did I pick x? Again, my hint was try to pick a letter that has a coefficient of 1. That's going to make it easy to figure out how to do the elimination. If you pick an equation that doesn't have a coefficient of 1, then you're either going to get into fractions or you're going to have to multiply both equations by something. I'm trying to get away with just multiplying one equation by something.
So if there's no equations that have a coefficient of 1, you're going to have to deal with it.
Then you're going to have to multiply both equations to fix it. Yeah. Okay, so first thing I'm going to do is I'm going to copy down the equations so I have some space. So I'm going to put 2x plus 3y minus z equals -1. And equation 3, x plus 4y minus 3z equals -8. I want to eliminate the x's. So what equation could I multiply by something that would make the x's cancel out? And this is why I picked one that just had an x. Yep.
Multiply the bottom equation by -2.
Yep. Multiply the bottom by -2. So let's do that and keep the top the same. Matt, what do I get if I multiply the bottom by -2?
-2x plus -8y plus 6z equals 16.
Okay, we want to double check. So we got -2x minus 8y plus 6z minus 16. Perfect. Now add them up. What happens when we add all the columns up here?
The x's are going to cancel.
X's are going to cancel. That's exactly what I wanted to happen. 3y minus 8y gives me how much? Yes. -5y. Y. What about -z plus 6z? 5z. And what about -1 plus 16? Yep. 15. Now, normally I would just stop right there and leave that as one of the equations I'm going to use. But something special happened in all three terms here. And because this happened, I can make this equation even a little simpler than it is. This step I'm about to do is unnecessary, but it makes it easier. What could I do? Yeah?
You could divide it all by 5.
I can divide everything by 5. So I end up with -y plus z equals 3. Okay, and I'm going to call that equation 4. Now my goal is to get one more equation like this with just a y and a z in it. Because if I can get one more that just has 2 letters in it, then I can solve this just like we did the last problem. I'll have 2 letters, but I need 2 equations. So we eliminated x from equations 1 and 3. We need to eliminate x again. But don't use equations 1 and 3. What equations could I use to eliminate x again? Besides 1 and 3. Yeah?
1 and 2.
I would, all right, we're going to get into lots of fractions though, because we don't have a 1 in front of either variable there.
Yeah. 6 and 3.
I would do 2 and 3, right? Because this 1 is going to make life very easy. Right? So let's eliminate x in equations 2 and 3. And that's going to give me another equation just like that. So eliminate x in equations 2 and 3. And let's copy them down. So 3x minus 2y plus 2z equals 15. And x plus 4y minus 3z equals -8. So what would we multiply by, and which equation would we do it to make the x's cancel out?
The bottom by -3.
Yep. Let's multiply the bottom by -3. All right, top stays the same. 3x minus 2y plus 2z equals 15. And Eli, what do I get when I multiply the bottom by -3?
You get -3x
-3x, yep.
and -12y.
-12y, okay.
And then plus 9z.
Plus 9z, yep.
And then positive.
Positive 25. Okay, let's add those up. And that's going to give me another equation with just y and z in it. X's are gone. What do I get for my y's? Yeah. Negative 14y. For my z's, I'm going to get 11z. And for my constant, I'm going to get 39. So now we've got equation 4 and 5. And we've taken this problem and we've turned it into a simpler problem. Now all we have is 2 variables left and 2 equations. Now it's the kind of problem we've done before. So now let's finish these 2 off and get one of our answers. So let's eliminate something in equations 4 and 5. So you can write them down, look at them for a second, and see if you can figure out which letter would be the easiest to eliminate. Yeah.
Would it be Z?
Yeah, I would say we could do z. So let's eliminate the z in equations 4 and 5, and then we'll have this down to the simplest kind of problem you can have, which is a single variable and a single equation. How would you make it so you could eliminate z?
I would multiply by -11.
Okay, so let's multiply the top by -11. So bottom stays the same. And how about, Chris, what's the top going to become?
That would be 11y plus minus 11z equals -33.
Okay, add them up. 11y minus 14y is -3y. What's -11z plus 11z? It's gone. And what's -33 minus 39? Let me just check something. Okay, yeah, what's -33 minus 39? Yeah. -72. And now the last step, divide by -3. So -7.
It's not -39, it's +39.
Oh, did I copy it? Oh, I don't know why I copied it. It's not -39. That's what I was looking at. Something looked weird. Luckily, it didn't mess us up that much, because we didn't finish yet. What's -33 plus 39? Sorry about that.
6.
6. Well, that makes y a lot easier. What's y? Yep. -2. And once you get your first letter, you're like 90% done the problem. Okay, you've really done all the hard stuff. Now substitute it back to get your other variables. I would use equation 4 to now solve for z. I mean, you can use 5 if you want, but I think 4 is easier. So -y plus z equals 3. So negative negative y plus z equals 3. Right, well, negative 2 is 2. And that means z is what? 1. And so now we've got z, we've got y. Last thing to do is find x. To find x, you got to go back to one of the original equations. Pick whichever one you think is the easiest. Which one you think is the? I think one of them is the easiest here for the same reason I used this one when we started the whole problem. Yep. 3, because the x has a 1 in front of it. So x plus 4y. X plus 4y minus 3z. So minus 3 times 1 equals, I forgot what was on the other side, negative 8. Alright, so we finish that, and then we finally have x. So x minus 8 minus 3 equals negative 8. What's negative 8 minus 3? So negative 11, which means x equals how much? Yeah, 3. So once you get used to the method, solving a 3x3 system isn't hard, it's very tedious. Right? If I zoom out, you can kind of get an idea of the work. We had to do elimination 1, 2, 3 times. So we did elimination 3 times, and then we had to do substitution twice. Okay? We did substitution once to get z, and then we did substitution once again to get x. But using this method, that's pretty much as efficient as we can be. Is this the best method to use? No. There's a faster method, but it requires understanding matrices, which is a whole other topic. So without trying to teach you another new method and just using what we already know, that's the best. Yeah.
Can you do 4x4?
Yeah, I can. I'm not gonna, but yeah.
But like, can it just go on and on?
Sure. Yeah. Eventually, you just start doing it so many times, you just get confused. You're like, wait, what? And then you get lost. You can just get confused. So it's very easy to make a mistake. A much better way to do 4x4 would be with a matrix. And that's a much more organized way to do it. So you have less of a chance of getting lost in the problem. And you have less decisions. Like here, you got all kinds of decisions. It's like, all right, what variable do you want to eliminate? And what equations do you want to pick? We had to make that choice several times. 3 times. With a matrix, all the decisions are made for you. So you just have to do the same method every time. And because all the decisions are made for you, a matrix is the way you would set up a computer to do it. Okay? Because computers aren't just going to randomly guess on how to do something. Like, okay, which letter should I pick? And then what numbers should I use? Computer's going to follow a method. And that's what makes matrices nice for people who like the same exact thing every single time without any guesswork. So I'm not going to go through this whole one, but in a problem like this, something that might help you out is the fact that you had a 0 in that spot. Zeros are always nice because you already have one letter eliminated for you in this equation. So that may save you a lot of time. If you choose to eliminate y, which I might do in this problem, you're already halfway done. This equation has x and z, so make another equation with just x and z. And then you can avoid one whole round of elimination like that. You can take that whole step out. Okay, so I told you I mentioned what a matrix is. I'm not going to go through how to do it. I'm just going to show you what it looks like. But a matrix, if I was going to write this problem down, would look like this. That's the matrix representation of this problem. Okay? It does a couple things for me. One is it turns everything into a number. In a matrix, there are no letters used when you're doing all your work. So it cuts down on the amount of writing you have to do. The 1, the 2, the 3, and the 1 are the 1, the 2, the 3, and the 1. Those are my coefficients that were in front of the variables, and that's why this part is called the coefficient matrix. This part that I added onto it, or this part that I augmented it, that's the word that they call it, it's augmented, are the numbers that were on the other side. And that's how you set up a matrix problem. And then from there, you do stuff. Is there any questions on that? Okay, so this whole process we did here, this was called elimination. Okay? That's what we focus most of today on, elimination. On the test, you'll be able to pick whether you want to use elimination or substitution to solve problems. All right, let me just double check homework. Just going to do 1 through 17. Okay, so 1 through 17 odd. Okay, so reminder, I'll be after school today. I'm going to pause the video here. I'll put the topics that are going to be on the test in the video. And then if you have any questions after you see the topics, just let me know. Yeah.
I think I might be able to
No.